Okay. All right, so this is problem 4, right? Mm-hmm. So we can just talk. This is the one about the noise. You can. Okay. Can you see? Probably not, right? Is it too far away?
If I need to, I'll stand up and look.
Okay.
It's fine.
Can you see it?
I can see.
Okay, cool. All right, so this is the one where what your utility of noise in what is it? Noise in watching the game, N and W.
Yeah.
Is it N times W, right?
Yeah.
Okay, and then, but the noise plus W is 60, right?
Yeah.
Okay, so how do I maximize my utility given this? Okay, so can I choose both N and W? I'm choosing both, right?
As long as they combine.
Exactly, but essentially I'm just choosing one number,
Yeah.
right? Which is like, because the other one has to be 60 minus that, right? So do you want to, so the first step is to put it in terms of just one thing. Okay, so what do you want to do it with noise or watching?
Noise.
Okay, so then this will be N, and then W is going to be what? Well, W is just 60 minus N, right?
Mm-hmm.
So it's going to be N times 60 minus N. So if I read my utility in terms of N. Okay, is that right? Okay, that's working. All right. So I post them on YouTube. That's people seem to like it.
Cool.
Anyway, okay, so N times 60 is what? 60N, and this is what? Minus N squared. Yeah.
Mm-hmm.
Okay. So if I'm just one person, how do I find the N which maximizes this? Take the derivative. Okay, so what is that? The derivative of 60N is going to be
minus 2.
yeah. Just this is derivative. This is 60, right? The derivative of this is minus 2N. Right? And set that equal to 0. This first order method. Then I solve for N. 60 equals 2N. N equals 30. Okay. So if I'm just one person, I spend 30 minutes making noise and 30 minutes watching the game. Okay?
Mm-hmm.
Makes sense? Okay. Did you guys get that?
Mm-hmm.
Okay.
I
you
get it, but I sort of, I mean, I have some more fundamental questions, I think, and that sort of is what's tripping me up. I can do the math, and I have no problem, you know, simplifying the utilities and finding the derivatives. I'm okay with that, but I don't know, maybe it's just problems with the language, like I told you my situation, I'm unfamiliar with it. But it's hard for me to work through, and it's probably just because it's a new concept. Like even when you were describing the dominated thing, you know, watching you go through the spreadsheet and how you were eliminating stuff, that was kind of difficult for me. So yeah, I mean, I can get to this point in all the problems, and it seems like they all follow the same pattern, where you know, the first thing you do, the utility is defined, you simplify the utility, you find the derivative, you put it in terms of, you know, which utility you're finding, and so that's good. And then so that is all you really need to do, and then you substitute to find the Nash equilibrium, right? So that's not a problem for me. But some of the other things, and I should have printed out my copy. I was working off the computer, so I don't have the home computer. But that was some of the stuff that I was tripping.
Oh, we can talk about that. Yeah, I mean, you know, so yeah, I do assume stuff about Nash equilibrium and all that stuff. You know, for people who took PS30, but you know, but we can still talk about it. Okay, anyway, so we'll just for now we'll just go on with this. So this is person 1, right? N equals 30, and W is, I guess, 32. It is 60 minus 30. Okay, now let's do the person thing with 2 people. That's the B part, right? This is A.
Yeah.
Did you guys get this?
Yeah.
Oh, you did? Okay. Oh, the only problem is the last bit then.
Yeah, it was when we're adding a large amount of people or 2 people. I was just unsure how to define.
Okay. Okay, so for the viewing audience, we'll do B very quickly. So so how did you do it?
For 2 people?
Yeah.
Well, I broke it up into N1 plus N2.
Okay. Can the view do the same? Okay. So yeah, so N1, where is it? Down here, right?
Mm-hmm.
Okay, yeah, here. So yeah, N times N, yeah, N1. So N is now N1 plus N2, right? And so now your utility is 1 plus N2 and W1. Oh yeah, so you substitute. Yeah, so you substitute N1 is going to be 60 minus W1, right? And N2 is 60 minus. Oh, okay, this is fine. So you're just leaving that on 6. So you take this is the derivative. You take it with respect to W1. 60 minus. Yeah, this is fine. Okay, and then.
The rest is on the.
Okay. So you get this, right? This is the best response for... You did in terms of N's or W's?
I forget which one.
Oh, you did in terms of W's. Okay, yeah, so this is W's, right? This is your best response for W1. Best response W2 is this. Right? And then you solved... N1 is... So N1 is... What is it? Oh, okay, yeah. You solve for W1 here, and then you solve for N1 right here. And then you solve for W2, and then you solve for N2, and then now you're putting this N1 and N2 together, right? Yeah, this is N1, this is N2. I'm marking all over, is that okay? Right. So you're solving for these two things, right?
Yeah.
And then you get N1 equals 20. That's good. So this is perfectly fine. Let's see what you did here.
It starts at the bottom.
Okay. This is correct. You good? This is N equals N1 plus N2. So this is... Oh yeah, okay, so this is the key part. This is your special utility in terms of N1 and N2, right?
Yeah.
So this is right, so N1 plus N2. This is the total amount of noise. This is like your W1, right? You expand it all out. Take derivatives with N1, and then you get N1. Yeah, this is good. And then you find the best response with N2. Yeah, so book at 20. Yeah, excellent. Okay. Did you guys get this too?
Yeah, that makes sense.
Okay.
I was doing N1 and N2, or
Okay.
N1 and W1, but I should be doing N1 and N2.
Okay. Either way is fine. You could do W's or N's. You get your chair too.
I'm about to get up actually.
Oh, okay.
I'll take my spot.
Okay. All right. Okay. Are you sure you're okay?
Yeah, I'm
Okay.
good. That
All right,
helps a
good.
lot.
Okay. Good. Okay. So right now we're for the M people we're talking about, right?
There was...
The only way I could do it was backing it out. Like I just went back to the first couple and figured out like an equation to make.
Oh, that's pretty good. Yeah, that's good.
That
just sort of following a pattern.
Yeah.
It turns out it does work that way. What did you say?
But is there like another way to
Yeah,
set
there's a
it
way
up,
of doing
or
it,
is that
yeah.
okay?
This is kind of okay, but sometimes it won't work.
Okay.
Like in a more complicated situation, it might not. But it's good to guessing is always a good thing. Yeah. So, but I'll show you how to do it. Did you say something?
No.
Okay. All right. So okay. So yeah.
Yeah,
Where's the
but I got
stuff?
stuff.
Okay. Let's see. So let's do it this way. So we're talking about the noise and the.
Yeah, I was.
Okay.
I got A and just
You
B.
got A and B.
I did get A. I did not get B.
Okay.
And then
So
I
B.
also found number 2 as well.
Okay. So B is we just talked about. B is this. So the way you set it up is. So the A is just setting. Is just this, right?
Yeah.
W is just 60 minus N, so you can do this, right? So now, when you have two people, N is N1 plus N2, so you can write it down as in terms of N1. So this is my utility. Now my action is just N1, your action is N2. So my utility is N1 plus N2. This is the total amount of noise times 60 minus N1, which is like my W1.
Right.
So you have this equation. So this now again expresses your utility just in terms of N1 and N2. I take the derivative with respect to N1 and set it equal to 0. I get this.
Okay, so you just put everything in terms of N1 and N2.
Exactly right.
Yeah, that's what I messed up on.
Exactly.
That makes sense.
Yeah. Okay, so now let's do the C part, really.
Oh, but on B, how do I show this, set it up as a strategic one game?
No, that's what you did. When you say that, so,
Okay.
right, so essentially your action is N1, right? And my action is N2, so this is utility of person 1 as a function of, your action and my action. That's what a game is.
Okay.
That's all.
Oh, so I didn't have to do anything.
Yeah, this, in a sense the key part is just figuring out this part. Is just to realize that you can express everything in terms of N1 as opposed to N1 and W1.
I get you, because I remember in 30, I didn't have 30 with you, but
Right.
the basic strategic form game is a sequential matrix.
Right,
So I
exactly.
was like, how am I going
Oh, right.
to
No, just like when in our class, it's a strategic form game simply is a specification of payoffs for every.
Okay.
So
Okay, yeah.
it's just like writing down when you write down the U1 and U2, that's
Yeah.
it. Yeah.
Cool.
Yeah. Okay. Let's do 4C. So, oh my gosh. Okay. We should move.
I got the good one.
We could move to the other. Okay. All right. See.
Thanks.
We could. Let's just do this, and then we'll move to the TA room, and we can be a little better.
You want to sit there?
You can go ahead.
Well, I'm just gonna stand up to see him do it.
Oh, okay.
So we'll just do this, and then we'll move because it's okay. So we're doing the noise problem.
Okay.
Did you do the first parts, or did you?
I did A and B,
Okay.
and I didn't get to the.
Okay. All right. Yeah, so the C is the part we were doing. Okay.
Okay.
So now. So again, last time. So now U1 is going to be a function of what now? There's M people, right? So it's going to be what? N1, N2, all the way to nm, right?
Yeah.
Okay, so what is that going to be? Okay, this is a function of n1 to nm. Remember so how do I write this? So it's kind of like what I did before, right? Here you did it, it's n1 plus n2, that's the total amount of noise, times the amount you're watching the game, right? So what's the total amount of noise?
So n times
plus
n.
W.
Yeah, well, it's adding these all up,
Yeah.
right? That's all it is, right? Before it was just n1 plus n2, now it's n1 plus n2 plus
Right.
n3, blah, 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 all the way in. So it's n1 plus n2 plus blah, 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 nn. That's the total amount of noise, right?
Yeah.
And then I'm multiplying it by what?
W.
W, right? Which is in this case?
W1.
Yeah, W1,
Yeah.
exactly right. Which is... you
60
did-
minus.
Oh,
Wait, why
60
is it-
minus.
60 minus n.
Because remember, your utility is NW, right? Remember? Where N is the total amount of noise, and W is how much you're watching the game. Okay, so it's exactly analogous to this, right here.
Yeah.
You see, the 60 minus N1 is how much your W1 is. The only thing which changes is that instead of N1 plus N2, I have N1 plus N2 plus N3, blah, 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 all the way in there. Does that make sense?
Yeah.
Okay. So this is going to be what? 60 minus N1. Okay? Alright, so this is your utility. Now, I think this is all okay now. How do I find my optimal N1? How do I find the best N1? Let's just look at what we did before, right? Here. You take the what?
The derivative
The derivative with
of
respect to
n1.
N1, right?
Yeah.
Okay, so how do we take the derivative of this with respect to N1? Okay. So again, we're not doing anything different. All we're doing is simply just, again, instead of 2 people, we have n people. Okay. So I take the derivative with respect to N1. How do I do that? Well, let's expand that a little bit first. It's a little easier. So this is going to be what? 60 times N1 plus 60 times N2 plus blah, 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 plus 60 times Nn. Right? And this is going to be what? Minus N1 squared minus N1 N2 minus N1 N3 blah, 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 minus N1 Nn. I'm just multiplying it out.
Right.
Is that okay? Again, that's exactly analogous to this. Right? You can see that.
Yeah.
Just when you're 2 people. Okay, so this is your utility. I take the derivative with respect to N1. Okay, which is what? Okay. So derivative of this with respect to N1? 60.
So we see that.
What's the derivative of this with respect to N1?
0.
0, right?
Yeah.
These are all like constants with respect to N1. So there's a bunch of zeros. What's the derivative of this with respect to N1?
Is that
Minus
It's
2
a square.
minus
Exactly, it's a square, so it's minus 2N1.
Everything else would be 0, right?
Well, no, hold on. There's an
Yeah.
N1 hitting these things, right? What's the derivative of this with respect to N1?
Negative n.
Negative
Yeah.
N2, right? And it's exactly, literally exactly like this. It's analogous.
Okay.
Okay. And then what about the next one? Will be minus N3, right? The
Yep.
derivative of this is down N1, right? Then I have all the way down boop, 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 minus Nn. Okay. Okay. So then I set this equal to 0 and I solve for N1, right? So what do I do? I'm going to bring my 2N1 over here. I get so 60 minus N2 minus N3 minus boop, 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 minus Nn equals 2N1. Right? Oh my gosh, okay. We'll get done. We're just doing the C part for C, but then we'll go to the other room. You can talk there. Okay. Alright, so then what? N1 we can divide by 2. Oh gee, sorry. So that's it. Oh. Okay, so N1 I divide by 2, I get 60 minus N2 minus all these things, right? Minus Nm divided by 2.
Right.
Okay, again, that's exactly analogous to this. Okay, makes sense? It kind of again looks the same, right? It'll be a
Yeah.
30 minus half or something, right? Okay, so this is clear? So in theory I could do this with N2, N3, and etc., right? But I said I think there's a Nash equilibrium which you assume that they're all the same. Okay, so assume that N1, say, is X. Okay, and N2 is X, and N3 is X. I assume that they're all the same, and Nm is X. So I'm just going to stick X in here and then solve for it. Okay? Right, so what do I get? I get 60 minus x minus blah 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 minus x over 2 equals what? What did I put in there? X, right? Okay, so this is not that hard. What's this going to be? This is just a lot of minus x's, right? But how many of them are there? There's m minus 1, exactly. Because there's no n1. Yeah. Okay, so there's n minus 1. So this is going to be 60 minus m minus 1 times x over 2 equal to x. Now I'm going to multiply both sides by 2. I get 60 minus m minus 1 times x equals 2x. And I think now, can you get this to work? I'm just going to see that. This is 60 minus mx plus x, is that right? It's 2x, yes? I'm just multiplying the x in there.
Yep.
And then I get, I'm going to take 60 now, is going to be mx minus, sorry, plus x, right? I'm going to take my x over here and take it out here. I'm bringing my mx over here. Is it okay? So this is equal to m plus 1 times x, 60. Okay, so then x equals just 60 over m plus 1. Okay, that's what I got. Now, like, interestingly, you can check it. If m is 1, what is x going to be? In this case?
It's going to be 30.
30, right? But that's exactly what we got when you did for the one-person case, right? One-person case is 30. Yes? If m is 2, then x is what? 20, right? But that's what we got here. Right? That's this. Okay, so it works.
So what made you allowed to set, or what allowed you to set every n equal to x?
Oh, okay, because so one reason is just because I told you to look for that. Because you can simply assume it. Another way to see it is that if I do the same, look, okay, think of this equation here, right? If I did this, so I can, if I did the same thing with n and I, what would be different? See, what should I say? I can bring a, okay, if I subtract a minus n1 over here, right, and this becomes n1, like this. So then I just have n1 plus nm over here, and I have n1. If I did it with an ni, it would be the same thing. So ni would be this. Right? Everything would be the same. So since then you could show that n1 equals n2, because all of them are equal to this thing. So then you could show it that way. Okay, let's move to the other thing, and then we could have more space.